Hi friends, welcome to the Unit 5 Day 3 notes. This is over nonlinear systems of equations and inequalities. One of the first things that I want to jump into is the discussion about how to visualize the solutions. When you solve nonlinear systems, visualizing the parent graphs is really important to understand the possible solutions. Remember, solutions are where the graphs or the equations intersect. So we're going to be talking about equations first, and then we'll get into inequalities. So think about this just in a general concept. How many ways can a circle and a line intersect on a graph? So I could have a circle and a line not intersect at all. So that would be no solutions. So no solution. So that's one case. You could have a circle and a line barely touch the edge of a point on the circle, and we call that, when something barely touches something, we call that's a tangent line, and that is one solution. So when you have it just barely touch, that's one solution. And again, that's called a tangent line. And then you could also have the line go through the circle on one point and another point. We call that endpoints. Doesn't necessarily have to be in the middle-ish like I did where you have the diameter. It could be just off to the side as well. And that would be two solutions. So these are the different types of solutions that you could have with a circle and a line. Go back for a bit. Think about the equations of these. For a line, you have it y equals x is the parent function. And then for a circle, you have x squared plus y squared equals r squared. Notice the degree or power of these. The degree or power of the largest one is 2, so you're going to have up to 2 solutions. Remember, you can't have more solutions than the degree or power of a particular equation. So with that under our belt, let's go into example 1. It says, identify each equation in the system, then determine the number of solutions possible, finally solve the solution by graphing. So here we're going to talk about, this is a circle, and then this is an equation of a line. This is a circle with a center at -1, -2, with radius of 2. So its center is at -1, -2, with a radius of 2. And this equation of the line, so let's see, if I subtract x, actually I think it's easier if I just add y on both sides and then subtract 3. So if I add y, subtract 3, that gives me x minus 3 equals y, or y equals x minus 3. So my slope is 1, and my y-intercept is at 0, -3. So if I think about this, this is going to have 0, 1, or 2 solutions. Let's go ahead and find the solutions by graphing. I'm going to graph the circle in red. Hopefully it shows up okay. So the center is going to be here. Now remember, I'm using the center to get the point on the graph, but it's actually not going to be a part of the graph itself. The radius is 2, so that puts a point here, 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 and here. And then I'm just kind of drawing out, hyper-focusing on this circle here. There we go. So that's that part. And then the equation of the other one, so the circle was in red. So then in purple, again, I'm hoping that you can see the difference here. X minus 3 is here. So then I'm going to have points. My slope is 1/1. So here, this is where I comment on I should be connecting these with a straight edge. So my solutions are those 2 points. So we have 2 solutions. It actually gave me solutions that were very easy to spot in this case. So let's talk about that for a second with the solutions. Oh, I ended up grabbing black instead of purple. That's okay. At least you can see that there is a difference between the line and the circle. So the solutions are 1, -2. So this is purple. Not much of a difference color-wise, but hopefully it's helpful. 2, 3, 4, and then -1, -4. So those are solutions to both of those, to that system of equations. So just real quick, if I just had a tiny bit change, if the center was 1/2 unit down, that would change these solutions. It would be really hard to solve this by graphing with this particular graph, just the way that it's set up with having it would non-integer solutions. So graphing has its limitations. It's great to hand graph and to have that skill and then to understand for other scenarios or cases. Let's talk about this. So this one's just slightly different. So we have, this is a circle with a center at the origin. So this is the center at 0, 0. I know that because I'm not adding or subtracting anything to the x or the y value. And then the radius for this is 5. So center here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. So now, doing a rough sketch of this, the bigger the circle, the worse my sketch is. Okay, so there's that one. The other one is a quadratic. This is going to make a parabola. So it has a y-intercept at 0, -5. That's kind of nice to see. So I know that the graph is actually going to intersect again 2 more times. Ooh, look at that. So with parabolas, now we're looking at the possibility with a parabola and a circle of not just 2 solutions. In fact, there is a way combining a quadratic and a circle is that you can end up with up to 4 solutions depending on where it is. So let's just talk about this. So this solution was easy to spot. It's on both parts of the graph. But when I make the quadratic and I go up to the next one, so here's my next points, and then 1, 2, 3, 4, and then 1, 2, 3, 4, 5. You can kind of see that it's starting to get a little bit difficult to see where these other solutions are. And I could be off. This actually could be where they meet up. So there's a lot of limitations with this sort of idea. This one is easy to spot. The other one's not quite so much. I don't know exactly the point where these two intersect. And so there's some limitations here. So this one I know for sure. I know that it's 0, -5. The other ones, I don't quite know exactly where that could be. So with that being said, in the next video we're going to talk about an easier way to solve, I believe. Unless you have technology, graphing is not the ideal way for most of these. Substitution is going to be a good route to follow. So I will see you in the next video. Bye, friends.